In this video, we're going to find the formula for the area of a triangle. Use the moving and additivity principles to find the areas of the triangles, then use patterns to find a general formula for the area of a triangle. Okay, so here we're going to use the moving and additivity, but also the doubling and the halving strategy. Okay, so again, remember, if I can turn this triangle into a rectangle, okay, then I know the formula for an area of a rectangle. So looking at this, I'm going to draw these two lines. Okay, and let's shade this in and consider this figure right here. Okay, so notice it's bigger than the triangle. Okay. Now if I look at the original triangle, which is in green here, this length is 3. And this length is 1, 2, 3, 4, 5. Okay. Now notice this is also a triangle. It's flipped upside down and the other way. Okay, but these are equivalent triangles. I can tell because this is 3 and this is also 5. Well, that means, okay, the area of the rectangle is equal to 5 times 3, or 15 square units. Okay, and our original triangle, since these two pieces are equal, it's one out of 2 copies of this, or 1/2 times 15. So this is the area of the triangle. Well, 1/2 of 15 is 15 halves, which is, well, just write it as 7.5 units squared. Okay. So now let's look at the next triangle. This one's a little slanty. Okay, we'd call this an obtuse triangle, not a slanty one. This was a right triangle. Okay, but I'm going to use the same idea. It's harder to make a rectangle out of this, so I'm going to go with a parallelogram. So here's the idea. I'm seeing that this is 3 units in length, so I'm going to go up here and find 3 units in this direction. Okay, now I'm going to draw a line from the end here to here. Okay. And notice I've made a parallelogram. Okay. Also notice that this triangle has an equal area to this triangle. Since this base is equal, okay, this side is parallel to this side, so they're also equal. So if I can find the area of this parallelogram, take half of it like we did before, then I can find the area of the triangle. So now with a parallelogram, we find the base, which is 3, and then we're going to find the height, and the height is actually this distance right here, the distance from the top base to the lower base, which is 1, 2, 3, 4, 5. Okay, so the area of the parallelogram is 5 times 3 square units, which is 15 square units. And since the shaded part is 1/2 of that, the area of the triangle is 1/2 times 15, or 7.5 units squared. Okay, so notice this triangle actually had an equal area to that triangle, even though they looked a little bit different. Okay, so notice, okay, when we had this right triangle, here was our base. We used another side of the triangle, but notice this side of the triangle right here is actually equivalent to the height of the rectangle. Okay, it's the side length of a rectangle, but it's also the height if we did the distance from here to here. Okay. Similarly, just looking at this triangle right here, I'm going to remove some of these numbers. So I removed the images, and it's just so you can get a bit better picture. This was our base, which was 3. And now the height of our triangle is a perpendicular distance to the highest part in the triangle relative to the base. Okay, so perpendicular distance, I have to go straight up. So going straight up is in this direction. And notice the height would have to correspond to the height of this vertex of the triangle. So we have a height of 1, 2, 3, 4, 5. Okay. So for the area of a triangle, we're also going to use the base and the height, just like we did with the parallelogram, but it ends up being 1/2, because when we make that figure, we get 2 copies of the triangle, so it's 1/2 times the base times the height.